Welcome to another episode of this tutorial series on MIDI programming in C#. Today we are going to do something very useful. Something that enhances your playing on a digital piano. We are going to split the keyboard into sections, or ranges. No, leave your axe in the shed. I don't mean split the keyboard physically, but behaviorally. On each section of the keyboard we will be able to play a different instrument. Many pianos offer a split function, primarily so that teacher and student can play on the same keyboard alongside each other. Usually with the same sound, and the split is limited to 2 halves. With our program, we will be able to define several ranges with a different sound on each. That's great, but there is more. Let's talk about velocity. In this context, velocity means how hard, or fast you press down on a key. In MIDI, velocity values range from 0 to 127. We can assign different sounds to different velocity ranges. Let's say you wanted a mellow piano sound when you play softly, and a bright sound when you play with more gusto. With the new enhancements to this program it will become possible. Let's begin with keyboard ranges. Now we are entering a realm where the capabilities of the keyboard we have available to us needs to be taken into account. So far we only dealt with general MIDI commands. All MIDI-enabled instruments would understand those. However, keyboard ranges are not part of the general MIDI specification. Roland and Yamaha both created their proprietary extensions on top of general MIDI. They are called GS and XG, respectively. In a Roland MIDI implementation document we find a section, where the data set 1, or DT1, message is described. There are fields for the memory location, where the data of interest resides. The data of interest now is the keyboard range, and we find it here. This is the address, and these are the possible data values. The same thing in Yamaha instruments, which implement XG, looks like this. This is the description of the message format, and this is where the data resides. In my program I will concentrate on Roland's version of the keyboard range MIDI message. If your digital piano does not respond to a keyboard range message at all, don't despair, there is another way to implement keyboard split. It can be done the same way as we will generate velocity ranges. In the program I will create the MIDI message first. We'll do the user interface later. Last time we already learned how to send a global parameter message to the MIDI device. That was in the MIDI out device class. Sending a data set message is similar. We need to create a memory buffer, in this case 11 bytes long. The header struct from last time is also applicable here. Only with another variable. And then, here is the code for placing the message into the memory buffer. All this can be written very quickly by copy and paste from the global parameter message code. With the appropriate changes, of course. Don't forget to also write the code to free up the memory when the device is closed. The method to actually send the keyboard range MIDI message to the device is called setKeyRange. The arguments are the channel, and the boundaries of the range, the low key number, and the high key number. Here is the MIDI specification again to cross-check these values. The X here is called a block number, instead of channel number. This is how the two are interrelated. In this method two messages are sent, first the low key of the range, and then the high key of the range. This message also includes a checksum, which is calculated here. Finally, MIDI out long message is a function in the Windows MIDI Media API. The message log was covered in tutorial 8. So, this was the device end of the code. Now let's approach it from the user interface side. And that means revisiting the channel user control. Here is my new display only field for the key range. On the Roland FP30 the full range happens to be from A0 to C8. I created a pop-up window for the controls where these values can be edited. That window pops up when the user clicks on the field with the right mouse button. Another event handler fires when the window is closed. I run the program so you can see how it looks. These are the note names, and these are the octaves. The pop-up closes when I click on it with the right mouse button. Simultaneously, a message was sent to the device and the key range set to these values. Here is the code that does all that. Some calculations, and the set key range method we looked at earlier. For the display I use this method to convert the note number to a musical note name. Let's do velocity ranges next. This will not involve sending a MIDI message. I'm going to start with the user interface for a change. On the channel user control I have another read-only field for the velocity range. The dotted line here simply means, a velocity range hasn't been defined for this channel. Just like with the keyboard range, a window will pop up when the user clicks on this field with the right mouse button. In my current implementation, there are three options. By default the velocity setting spans the entire range from 1 to 127. This here is a toggle button, and when it says 2, then the velocity for this channel will be between the minimum value and this value, chosen by the user. Let's say to 60. Alternatively, it can go from, say, 65, to the maximum value. Any guesses what this offset field does here? It works as a multiplier. When the sound of either of two instruments are being played on the same channel, based on their velocity, the one on the lower half of the range can sound too quiet, and the one on the upper half too loud. The offset can be used to balance their volume out. A positive number will increase the effective velocity, while a negative number will decrease it. Time to discuss the code. The event handlers are not very interesting. This is the code for the toggle button, and this here reacts to the up and down arrow keys on the computer keyboard, to increase or decrease the number in the field. It gets more exciting when the pop-up window is closed. I have a new class here, which contains an array of velocity range structs, with fields for the range boundaries and the offset. Each channel has one of these. Wonderful. How is it going to be used? You might recall that in tutorial 2 or 3 we covered the MIDI in callback function. Then I said we will do some interesting things here. Well, the time has come. Here is the incoming message handler. If a note on or note off message was received, Then for each active channel, if the velocity of the incoming note on command falls between the boundaries of our velocity range, then keep processing, otherwise skip the remaining code and don't play this note. Before we send out the note on command, we also modify the velocity by the offset. So, this is how it works. See it in action. While I am setting things up, let me say that the keyboard split function, in its current form, has a shortcoming. On the low keys you can only play low-pitched sounds, and on the high keys, high-pitched sounds. Sometimes you might want to play both instruments in the same octave range. In the next tutorial we will add a pitch shift capability to the program.